Hey guys, we are in our free online coaching classes for the NET examination, and this video will be the lecture 13 in this series. And the topic is the Introduction to Geophysics, and the book which I referred is the Introduction to Geophysical Prospecting by Dobrin, Outline of Geophysical Prospecting by Ramachandra Rao. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. And in this video, I will try to cover three main headings, that is, what is geophysics, why it is important to go for geophysics, and how does this method works. So these are the three main topics which I will try to cover. So let us see the first topic, that is what. Actually, the geophysics can be explained as the study of Earth using physical measurements at or above the surface. The geophysics involves the study of those parts of the Earth that is hidden from the direct view by measuring their physical properties with appropriate instruments, usually on or above the surface. It also includes interpretation of the measurements to obtain useful information on the structure and the composition of the concealed zone. So to be precise, the geophysical method works in the basis of observing the Earth's physical property and the change in the Earth's physical property with place to place, and by this you can interpret the reason for the change, and through that we can find the structure and composition of concealed zone which is actually not exposed anywhere on the surface. So this is what in short the geophysics. And in a broad sense, geophysics provides the tool for studying the structure and composition of the Earth's interior. Virtually all of what we know about the Earth, that is below the limited depth to which the borehole or a mine shaft have been penetrated, has come from the geophysical observation. The deepest borehole might have been touched, say, up to 8 kilometers from the surface, whereas the Mariana Trench is the deepest portion in the earth, which is, say, 12 kilometers below the mean sea level. So this is the maximum depth up to which a man can see. But we had already classified the total radius of the earth is somewhat near 6,000 kilometers, and we had classified it as crust, mantle, core. And all this classification had been made only on the basis of this geophysical observation. The extent and properties of the earth crust, mantle and core have been determined by the observations upon seismic wave from the earthquake, as well as measurement of the earth's gravitation, magnetic and thermal properties. So by measuring these properties, we had also classified the earth into different shells, and also we had find the composition of these different shells. So the geophysics is a tool and technique developed for the exploration of hydrocarbon and the mineral, and also used in academic research to understand the nature of the Earth's interior. So this is what the geophysics is about. And the second question is why. Actually, the extraction at the continually increasing rate of the fossil fuel and useful minerals from the earth has raised the specter of impending shortage that could threaten the economy and the way of life of the civilized world. Events in the mid 1970s have demonstrated how well founded this concern can be, where the amount of oil, gas, and metallic minerals that actually exist in the earth, both known and undiscovered, are of course limited. But the immediate problem, as established reserves become scarce, is to find new supplies in the earth, and that will replace those which have been consumed. Whereas the exploration for energy supply and mineral resources have been increasingly difficult as the EC source are actually discovered and exploited. To meet the challenge, Earth scientists have developed more and more sophisticated techniques of exploration. At the beginning of the 20th century, the search for oil and solid minerals was confined to deposits directly absorbed on the surface in the form of seeps or outcrops or other exposures. When all accumulation in an area that could be discovered by such a simple mean had been founded, it was necessary to deduce the presence of buried deposit indirectly by downward projection of geological information observed on the surface. But at this approach, approach reached the point of diminishing returns. The new method of studying the subsurface were needed. They involved physical measurements at the earth surface that would give information on the structure or composition of concealed rock that might be useful for locating desired deposits. So this is the thing why we are going for the geophysical exploration. And the last one is the how question. The geophysical, let me introduce you some of geophysical methods. They are the widely used methods or the seismic, the gravity, the magnetic, the electrical and electromagnetic methods. And let me explain you the how question with the help of this one example.
Fed up with online classes? Having trouble in interaction and discussion in online classes? Looking for one-to-one learning? Then you are in the right place. GeologyAssignmentSupport.com is here to help you in your studies. For more details, check our website. Link is in the description.
Example. So we will take the example as the resistivity method. The basic principle behind the resistivity method is the Ohm's law, which is stated as V is equal to IR. Here V is the voltage and I is the current and R is the resistance. The right side image shows a sketch of how the resistivity method works. So in this you can see there are four rods that is connected to the surface, right? So the first and last was a rod that is connected to a battery, which actually passes current to the earth surface. And these two rods are the rods that is connected to the voltmeter, which actually shows the voltage difference, right? So the current that is passed that we can measure in the ammeter here, and the voltage difference that can be measured in the voltmeter here. So if you know two things in an equation, you can find the third thing, right? So by this way you can find the resistance. The resistance change with the object, likewise the mineral. So when there is a change in the mineral, there will be change in resistance as well. The name of the rock is also changed. And the right side table shows some of the example of resistance value for different rocks. For example, if you take granite, the resistance is say 5 into 10 power 3 to 10 power 6 ohm per meter. Whereas in terms of shale and sandstone, it is say for shale it is 20 to 2 to 10 power 3 ohm per meter, whereas in terms of clay if you see it is say 1 to 100 meter ohm per meter, right? So likewise it is changing for every rock type. So we can find the change in the rock type with the help of the change in the resistance value. So if there is a change in resistance value from place to place, we can simply find that the rock type also changes with place, right? And by the detailed study we can also find the rock which is not exposed actually. So this is the generalized introduction of this geophysical method, and the how question is, I think it is answered. We will see detailed method in the next classes, and I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram. You can support us by like, share and subscribe. Thanks for watching. Have a great day.